Thanks everyone for joining today's Space Syntax Lab seminar. We are very pleased to welcome Dr. Federico Mara, who will be speaking on forecasting crime patterns, comparing space syntax and ABMs in exploring pedestrian movement and visibility. The talk looks at how space syntax and agent-based models, two very different kind of modeling approaches to urban space, can help us understand pedestrian movement, visibility, and patterns of urban crime. Federico is a postdoctoral researcher at the University of Pisa, where he's focused on urban planning tools and methods for analyzing urban complexity. His research centers on urban safety, crime prevention, and environmental sustainability, with a particular interest in how spatial configuration, environmental design, and perception shape social behavior. During his PhD, he investigated the role of visibility in decision-making and how spatial characteristics can influence safety. He's currently working on the DOT Horizon 2023 project, Evolutive Meshed Compact City, where he leads spatial analysis for the University of Pisa, and he's also involved in the Urban Transformation and Public Safety project. Before we start, just a quick reminder, if you have any questions during the talk, please feel free to post them in the chat and we will go through them at the very end. And with this, I'd like to hand over to you, Federico. The floor is yours.
Yes, thank you very much, Kimon, for the introduction. And you have done all the work presenting me, so I will just go into the presentation. So we are talking about simulation to forecast crime patterns, and I decided to start with the title of the last publication that we had with some colleagues of mine, so Diego Altafini, Valerio Cutini, and Nick Malleson from the University of Leeds, where I was a visiting PhD. And I decided to start with the title because actually it embraced all concepts that we're gonna face within this presentation. So the simulation, so we are gonna face the modeling tools at the micro scale, focusing on crime patterns. So in particular, the human behavior and risky places concept with the metrics behind this concept. Comparing space syntax and agent-based models. So there is this concept of this opposite approach of top-down versus bottom-up. In exploring pedestrian movement and visibility, so we are gonna try to extract these primitives to explore what we have defined spatial crime impedance, and we will see in a few moments what we are referring to. So as we work with space syntax, we are in this world of urban modeling. We know how difficult it is to model urban complexity. We are always struggling in selecting the relevant aspects, the relevant characteristics, the relevant dynamics, and trying to understand what's happening in particular within the city. And when we refer to the social behavior, is particularly hard because we are talking about people. And the first thing that we are assuming within this presentation, within my research in general in crime and in spatial analysis, is the relevant role of the environment. So we are starting with this assumption. So the space is not just a backdrop, but it's a fundamental aspect that is shaping our behavior within it. And in particular, we are contraposing as a top-down approach, the space syntax tool, let's say, the space syntax theory, and on the other side, an ABM developed within the methodological. As we know, syntax comprises a set of techniques that emphasize both material and immaterial characteristics of urban space, but its inherent lack of time component and the use variables limits its effectiveness in investigating crime dynamics, in particular if we refer to micro-urban scale dynamics. On the other hand, ABM simulate interacting agents capable of perceiving the environment. They can influence each other and they have the presence of the time component while we are exploring it. So these are, let's say, fixing one the other. So considering the environment, the first one from a top-down approach and the other ones in adding the time component. So the point is trying to compare these two approaches and trying to understand what are the results in terms of crime dynamics. And in particular, during my research, the questions that were driving my work were how can a model for exploring crime dynamics be designed to integrate both spatial and criminological components, and at the same time exploring what are the differences between space syntax and agent-based modeling when applied to the same scenario. So moving within this framework, I decided for this presentation to propose this simple outline. So going very briefly with the background, with the environmental approach security and the spatial crime impedance, which are actually the two pillars of my research. Then exploring the case study, why Pisa was selected, then the data sets that we used, that we collected for this very case study, and then the modeling construction with the theoretical assumptions coming from criminology, and then the spatial modeling with space syntax and ABM, and then some discussions about the results in terms of pedestrian flow, visibility, and finally risky places, and then some conclusions. So starting with the background, as I was saying, one of the pillars is the environmental approach security, so the focus on crime prevention. And in particular, within this, we, as I was saying before, recognize the role of the environment intended in both its components, so the spatial component and the situational component. For the ones working with crime, it's very clear because why we refer to the situational part, because we are always referring to the concept of opportunity for criminals. So we are working with these two components, and in particular, we are referring to the environmental approach security that developed from Gary and Ketelet. I here put just an image with the choropleth maps that they developed in searching for relations between population data and crime, arriving to the Ecology School of Chicago, passing to the what I've defined the American ferment with Wood, Jacobs, Angel, and then Jeffrey Newman with the defensible space and environmental and Septed, let's say, with Jeffrey, even if then it assumed its last shape during the next years with the help of the criminological support. So the criminological theories that I tried to systematize within this framework. So we can see here the different inputs that arrived. We can see the concept. Here I refer to the work of Wortley, Tansley Wortley in 2017. And we can see the type of concept that are categorized by types and by scale of analysis in the last column. So dependently of the time of investigation that we are doing, the focus that we have, we can select different theories. And after this systematization, we were able to select, we will see later, the theory that is supporting our model. So in the end, I just cite the septed, which was starting with the defensible space on Newman and then expanded, including several dynamics, so the social aspects, and in the end, the livability aspects, so the focus on the neighborhoods and how they can impact the citizens' quality of life. So the crime is just an aspect of a more of a bigger problem, of a bigger system. On the other side, we talk about spatial crime impedance. So on one side, we have the criminological theories and the environmental approach security. On the other side, we have the configurational approach. So the spatial crime impedance, as we have defined, recalling the spatial impedance has been defined as the natural resistance that the urban environment, considering just its spatial configuration and physical layout, opposes to criminal activities depending on the specific type of crime. Let's say that there is, within our work, the hypothesis that spatial configuration could determine favorable or unfavorable conditions, opportunities for crime commitment, and a lot of work, I've worked already on that. But there is somehow an attempt to, by extracting the intrinsic characteristic of space and combining them, depending on the type of crime, try to find some specific relation with types of crime and also fear of crime, which has to be explored yet. So again, the point is that we are using the urban configuration, so space syntax in particular, to extract to understand people behavior, and from people behavior by integrating within criminological theories, try to understand where the risky places hide. And this table here is, for example, a table of some correlations that we found within the case study of Pisa, presented in Cyprus at the Space Syntax Symposium, where some linear relation between some measures with visibility graph analysis and crime distribution showed up. So it's something interesting to assess within our studies. And in any case, today we are talking about just modeling, so this comparison between space syntax and ABM, and in particular, we focused on Pisa. I mean, I work within the University of Pisa, so it was, let's say, also the easy case to be studied, but it was selected not because of this, but because of its uniqueness. In fact, it's a city university where three universities are located with almost 50,000 students, and just 90,000 inhabitants. So almost 1/2 inhabitants is a student. So it's a little city, we can say it like that, under 100,000 inhabitants. And it's also visited by a lot of tourists because of the presence of the Leaning Tower, because of the presence of the airport and Florence that is really close to. At the same time, we have another aspect that is really intriguing within this case study. That's the fact that we are referring to a medieval city. So we have this composition of spaces made up of narrow streets and open spaces all of a sudden. And this creates, from the visibility point of view and also the perception of spaces, really peculiar characteristics applicable in some Italian cases in particular. The historical city centers that we are investigating, there's the one highlighted in red that correspond to the ancient walls, the red lines at the border. And in particular, the northwestern neighborhood is the neighborhood where the nightlife is concentrating. So we decided to explore this area, and here we have just a screenshot from Google Earth. We can see here the Leaning Tower. This is the western part of the city. And we're going to investigate this area here just to let you understand, and this one here. So two very close areas with same general characteristics, but very different characteristics than at the local and at the macro local scale. And in particular, these case studies are Piazza delle Vettovaglie, which is this place here, and Via Sedini that we'll see later. And here you can see some pictures about the square and the different, how to say, atmosphere that you can live within it just during one day. So we decided to select in particular this place because it's full of commercial activities, it's a commercial hub. There is a high pedestrian flow. It's a transformative area as we have defined it, so it's changing through time and just during one day. It's the nightlife hub of young people, of students, and is perceived as insecure in general, but also with the survey that we conducted. On the other side, we have Via Sedini, which is really close, but actually it's a completely different scenario. We don't have here commercial activities at all. We have still high pedestrian flow, but we have stable environmental conditions. So nothing is changing from the configurational point of view, but still it's perceived insecure, in particular at night in this area in particular. And you can see this area is this one here. So the picture was taken from here, in this direction and this direction. So given this background, we're going to explore the datasets that we were using for the models. And as you can see, we started defining these different time frames because they are corresponding to different situations within the area. So we had a survey of the type of activities and the time they were open during the day, as we can see in the table here. So we had a categorization depending on the type of activities. We have fast food, restaurants, shop, pub, and so on. So we have this type of categorization, and we can see all these commercial activities for Piazza delle Vettovaglie, and we have just the parking lots within Via Lusserini, which is the only things that is changing during the day. Our data are referred to May 24th, and we had these observations about commercial activities time, opening time, but also about the people count, the people working within the area. And to do this, we decided to have 9, let's say 10 virtual gates, 9 at the border enclosing the area completely, so that we had an evaluation of a precise count of the people going in and going out. And then the tent just as a control measure in the middle of the square. And we decided to register the number of people going in and going out for 24 hours. So from 6 a.m. From Friday 6 a.m. to Saturday 6 a.m. and register the data every 30 minutes. So for every 30 minutes, we have for all the 10 gates, for each of the 10 gates, the number of people going in and the number of people going out. And as you can see from the figure 12 here on the right, there is a certain hierarchy, a certain ranking between the different gates, which is interesting, and it's something that we have tested in the contribution that we have talked about in the Space Syntax Symposium, because let's say the ranking of the gates, it's almost the same during the day with some little variations. But the interesting point from the criminal point of view is that the conditions are changing a lot. For example, if you see the nighttime period, we have a lot of people, we have a crowded square since it's not that big. Other conditions are middle of the day while the tourists are just passing by, or people are passing by, students are passing by, and other conditions are during the square is almost empty. So these variations through time was taken into account with the people count. And also we had some qualitative observation of the phenomena taking place within the square. I mean, I'm from Pisa, so I know this area, but we made some qualitative observation during that day. Just a note, I forgot to tell, the people counting was not done during, I mean, on site, but we had cameras to count people. But for some privacy concern, we weren't, it wasn't possible to use automatic calculator, but we had to count them at the cameras with with an agreement that we had with the police, local police. So now let's move into the model. So the model's construction assumes what we have done, what we have said within the background. So after the summary of the criminological environmental theories, we went into and we decided to select the combination of the rational choice perspective and the routine activities approach, which can be synthesized in a very simple yet effective way with the crime triangle of Cohen and Felsen. So according to Cohen and Felsen, most criminal acts require convergence in space and time of likely offender, suitable targets, and the absence of capable guardians against crime. So this is a simple scheme that allows us to make some simplification and test if this can work with our modeling approach. So we started with this, and this was our basis coming from the criminological world. And we decided to translate these measures into key metrics, what we have defined, key metrics and behavioral metrics. So we translated the co-presence of the suitable target and the motivated offender into pedestrian flow, since it's probabilistically associated to it. And on the other side, the concept of capable guardian, the presence or absence of a capable guardian, to the concept of surveillance and then visibility. So arrived at that point, the last step that it was needed for our model was to translate the pedestrian flow and the visibility into quantitative metrics. And we know that space syntax provides theory and tools to do that. So we tested, and we did it not in the paper that I was referring to before, but for the, again, for the Space Syntax Symposium paper, we did this comparison between different types of analysis, different types of techniques, different environment extensions, and different metrics, trying to assess if what was the measure. The question were to if there was a correlation between the pedestrian flow that was registered on site during 3 days for this analysis and the space syntax measures, and what type of analysis was showing the best results. We know that from literature, axial analysis is very good in estimating pedestrian movement, and we were analyzing if even the visibility graph analysis was good to be used. So the results that we obtained were this one. So as we can see here, we have the different types of analysis. So axial analysis urban, axial analysis micro-urban, angular segment analysis at the urban scale. So is changing both the scale of the analysis and the techniques. And on the left, we can see the measures that show the best results in correlation with the pedestrian counting. So we can see that axial analysis showed the best results with visibility graph analysis, and in particular with point first and second moment and true vision. Talking with Penn during the conference, he told us, he suggested to increase the number of gates for further tests to consolidate, let's say, the analysis. But it was promising, so we decided to use, also because in the literature, the true vision is associated to the pedestrian flow, we used to test and to use the VGA true vision as a driver. So going back here, we decided to associate true vision, point first moment, second moment, and hysteria that showed good results, but in the end, we used true vision for the pedestrian flow, and for the visibility, control, and controllability that was cited also by Turner in 2004 as measures to be explored in criminological investigation. So we had from the top-down approach these two measures, and as a test we used, as I was saying, the visibility graph analysis, and we imposed a very fine-grained grid, 0.375 meters, for two goals. So lower the non-randomized grid impact that Dalton presented in Bergen in 2022. So having a lot of points, let's say having a lot of pixels with values can lower down the impact of the grid. And on the other side, have half human footprint that was assumed 0.75, also to have the opportunity to refer to an ABM studies that was using 0.375. So we were in this phase trying to model from the top down, but also taking a look at the ABM. So this was the results with the result with the true vision measure, for example. And on the other side, we did the ABM model within NetLogo. This one was most difficult because, as we were saying before, we have to impose the rules for our models. So we have to decide how the agents are going to behave. So we had the agents driven by the real data that we collected. So we had people going into the area from a gate and just aiming to arrive to another gate. So going from gate A to gate B, following the shortest path criterion. But then while walking within the space, things were happening. So there was for example, the attraction of the commercial activities. So if the agent was falling into a 30 radius pixel from the activity, it had a certain opportunity to decide to going in, for example. Then we have a differentiation between types of agents, so tourists, locals, and visitors, based on the model developed by Yamu and presented in Van Ness Yamu in 2021. So the tourists are moving with a 30 degrees view and walking one step and then taking a new decision on the direction and so on. so that they are just navigating, let's say, exploring the space, then the locals as intermediate agents, and then the visitors that are just walking by, then simulating the students or workers that are just crossing the square. And this analysis came out from the qualitative observations that we did about the different agents that were walking within the area. The environment is the same both in the space syntax model and in the ABM, so 105 meters square, and for a total of 2080 per 2080 pixels. So these were the base. And in the end, we obtained, as I was saying, the measures from one side, from the depth map that we calculated the true vision and the controllability measure. On the other side, we calculated the number of times each pixel was walked by and the number of times each pixel was viewed. So was into the field of view of each single agent. In this way, we had a similar map, an heat map in the end that was comparable. So passing to the results and discussion, we can see exactly here are the results. So the first observation to do is obvious, of course. Configurational estimation is timeless and therefore is unique, not only throughout the day, but overall, depending solely on the spatial configuration. And on the other side, the ABM presents a different distribution of flows for each time frame that we are analyzing. It's in particular regarding here, let's start with Piazza di Vittovaglia, which was our first case. Morning and late night time frames in DBM exhibit a more rigid pathways. And this is not due to a lower number of pedestrians, but rather to the higher presence of visitors compared to locals and tourists, since we had the opportunity to change these values. Additionally, the lack of open commercial activities fails to exert any attractive force. So they are just moving from one gate to the other during the morning and during the late night. And then the pathways become instead more varied during the central hours of the day, with the night time frame standing out due to the co-presence and widespread occupation of spaces. So we have this moment here where people are staying together within the center of the square, and it's a function that we added within the ABM. So people had also the possibility to decide to just stand within the square for a certain amount of time, probabilistically assigned. Furthermore, the southern accesses are essentially desert during the morning and late night, as we can see here. And this highlights from the criminology perspective potential temporally isolated areas, and this may increase low flow related crime opportunities and fear of crime, of course, especially considering the narrow spaces and limited field of view of that areas. And these portions actually appear to be weakly traversed according to the space syntax model too. So because of the configuration that they are having the lowest values of true vision. Then another observation is the east-west transversal axis. So we can see here that this axis is respected by both the models. So according both to space syntax and agent-based model, this is the most traveled area. I mean, I'm excluding these ones that were outside the ABM, of course. And this is consistent between the two models. So the space syntax was able to perfectly detect where the people are moving in reality. And the ABM, of course, since it's data-driven, was able to highlight that phenomena. On the other side, the case study of Violis Sedini reveals more regular dynamics. It was an easy area to be studied due to the lower numbers of variables, as I was saying, and the predominant flow is from north to south, south to north, in both models. And the ABM model, again, highlights that the most substantial flows occur during the central hours, of course, and shows how the different composition of pedestrians affects movement patterns. And another observation concerned the area leading to the northeast part, where cars' disposition influences paths followed by the pedestrian within the ABM. Here, the only variables that was changing was the position of the cars, and so people were deciding to follow the shortest path according to this only changing within the environment. Um, and I mean, although this little variation is not particularly significant in this case, it can let us understand how even a single changing within the ABM can give us very different results in the end. Just imagine if we were running the model for many days, maybe we would have a very trafficked area and a segregated one. So yes, and also by combining this information with other information that we can acquire from the area, like, for example, the permeability of the area or the lightning or the visibility condition in general, crime opportunities and fear of crime can change. So these are aspects that can be taken into consideration. So overall, the eastern portion of Violi Sedini here is, in the end, much more segregated compared to the model, to the space syntax model here. And this is quite interesting since to explore crime dynamics, since the space syntax model can be not that useful in exploring this aspect, since no people is passing from this area. So it's a different dynamics that emerge by the comparison of the two models. Okay, similarly, strong differences between the two approaches emerge in terms of visibility, given the changing of number of people passing by and the obstacles themselves represents in terms of visibility for the others. This is, I think, that I didn't say before. People are, of course, creating an obstacle to the field of view of the other people. So depending on the position of people, the field, the areas, the most visible areas are changing. So in general, here the open spaces gain medium to high values of visual controllability if we refer to space syntax, representing then easily controllable areas, as expected, of course. And in contrast, narrow streets in the southern portion, again, associate low values. So the controllability has low values within narrow streets. The same logic is represented within the ABM. Of course, visibility conditions change throughout the day. In particular, again, in the morning and in the late night, at late night, we can see that almost all places are, let's say, empty and not surveyed. And this means a high impact for crime and in particular for fear of crime. And the survey confirmed this aspect. Again, for the Violi Sedini, the dynamic was almost the same. Again, the visibility in the eastern portion was very low, and but again, also the space syntax showed this lower visibility potential with these low values of controllability, but the fact that no people is passing by was significant. So maybe with a higher area investigation, some space syntax measures would have understood that that area is actually segregated. But within this closed look, the controllability wasn't able to detect these, also because the controllability is a semi-local measure. So the values are these one. So in general, the two case studies demonstrate how variations in flows, the composition of pedestrian, open commercial activities, and visual obstacles significantly impact effective visibility, even when these variables are minimized, as this case of Violi Sedini. And notably, the differences are evident with the space syntax model that cannot account for effective visibility influenced by the number of people and the temporary obstacle they represent or the changing situations within the environment, leading to a representation that is not fully accurate, particularly concerning specific times of the day. I think that I forgot to say is that also how to say, the environment was changing a little bit with street furniture. I mean, the commercial activities during the time are using the space in different ways. So we have, for example, the local market at morning, then we have tables for tourists during the day, and then in the end, just people. And this, just to say that these dynamics are not taken into account within the spatial configuration, the classical spatial configurations, while with the ABM, we took this into consideration for the movement and for the dynamics that we were exploring. So arriving to, let's say, the combination of these two measures according to the crime triangle, we obtain in the end these results. So it shows that for the night time frame, we focused here on the night time frame, so from 9 p.m. to 2 a.m. And we are representing here the lowest 20% visibility estimated through space syntax modeling on the left, and the lowest 20% walked and viewed pixel from the ABM on the right. So we decided to choose the nighttime slot because in literature, for example, by Newton and Felson, it corresponds to the highest risk of robbery. So we selected this time frame for this investigation. And in purple, in particular, are highlighted the riskiest areas, let's say, because these are the areas where the, as I was saying, lowest controllability and lowest true vision are overlapping. So the interesting fact is that in this case, both modeling approaches identify actually analogous risky areas concerning robbery, but with some differences that are in particular related with the center of the square. And this is done because, of course, the IBM could take into account the presence of people that were creating obstacles within the area, and so some hidden places where crimes could have been committed. On the other side, within Via Sedini, happened the same situation, let's say. So similar dynamics, but the eastern portion again is assuming very low values of both flows and visibility due to the low numbers of passers-by. This precisely demonstrates how, in general, the logics by the two models are in general similar, but at the same time, it's clear how the ABM can prove particularly useful in investigation at the micro scale, both from the spatial and from the temporal point of view. And therefore, we can say that the bottom-up model of flow invisibility proves to be crucial from a criminological standpoint, with ABM useful to identify areas that, for example, due to high concentration of people, might offer favorable or unfavorable conditions in the eyes of the, of course, potential offender for committing a robbery or a pickpocketing or whatever types of crime, depending of the situation, the contingent situation. And in these specific scenarios, by observing the models, we can say that Piazza delle Vittovaglie is offering high pickpocketing opportunities at night due to the high pedestrian flows and co-presence, while in Via Sedini, that we can see here, this risk is related to street robbery, in particular within the eastern side, where there are no passers-by, when there is no surveillance, where there is no sense of belonging of the buildings because there are no direct access to houses and so on. Actually, both these areas are affected by, this is an interesting thing, high drug dealing rate, as emerged from another study that I've done before, presented in Bergen during the Space Syntax Symposium. And this actually works within this area because pickpocketing and drug dealing actually are quite similar, at least in the beginning. Let's say, because we need a lot of people and a lot of potential targets and demand that offering and demand that are meeting, and then that are having the drug dealing crime. But last thing that I would like to say is that has a huge impact the sense of belonging, as I was saying, of the inhabitants. In both the areas, in particular in this one, there are no inhabitants facing the area. There are no direct connection from the houses to the eastern portion of the street, and just a few along this street. And also there is another problem that since the city is a touristic and a city full of students, the houses are rented to students, are rented to tourists that then are not developing this sense of belonging to the place and this yes, the sense of belonging that the septet talks about. So referring to Newman now, there is no opportunity to create this sense of belonging, and so these parts of the cities rest, let's say, segregated. So this is a thing that we considered while discussing this model, but it's a limitation that this model doesn't have since there wasn't this additional information to be added. If, for example, within this area, we would have a lot of houses entrance, a lot of windows or commercial activities, the scenario would have been very different, and the model should have taken into account these differences. In the end, we just did a test trying to combine the space syntax and the ABM using the ABM, so the ABM as I already presented, but integrating the true vision as a driver for the agents so that they could have moved more, how to say, not with a strict path following the shortest path criterion, but actually these things, this additional information created some problems after the more than 10% calibration. I don't know how to say, but we integrated these pixels as a driver for the agents, but the model wasn't responding well, so we decided just to put this one here as a sort of inspiration and to put it on the table to discuss it. And we can see some little improvement within the movement of the agents that are not following just a strict path. But again, we still have to test more in depth this combination. And finally, arriving to the conclusions, I mean, I think I've already said many of them, but today we compared with this analysis the differences between top-down and bottom-up approaches, specifically space syntax and agent-based modeling, in interpreting pedestrian movement, visibility, and ultimately in defining risky areas through the construction of an interpretative framework of environmental criminology. Space syntax is better for estimating general flows, but lacks in addressing temporal issues, as we have said, while ABM can be as detailed as desired, but demands a substantial amount of data as input, behavioral assumptions, which is the biggest problem while designing an ABM, and timing construction. ABM is superior in responding to very specific needs due to its high degree of customization, yet depending on the modeling rules that we have to assume while we are designing the model, and the ability to include the temporal component, which is crucial in the field of crime prevention and in general in exploring in detail social dynamics at the macro scale. As anticipated, even from the simple case study conducted, considering a rather basic interpretive framework, substantial differences in estimating pedestrian flow, visibility, and potential risky areas emerged. Yes, and given the BM potential in exploring how even little initial variation could influence the final outcome. So it's interesting to assess now how little variations within the ABM can change the final outcome. So as further developments, I put this one here. So just to briefly conclude, the ABM included numerous variables, all justified from a methodological perspective. We didn't have that time, so I'm open to questions about that, but we respected the literature. We put within the paper a lot of references about that. But however, it is now necessary to operate with more rigor and analyze the impact of each of these variables that we have combined here to showcase and to bring to the extreme the modeling just to show what type of results we can obtain. And the complexity of the ABM did not correspond to a similar complexity regarding the underlying interpretative criminological framework. So there is also the possibility to test other criminological models behind the ABM and space syntax models. So just to conclude with further direction, we have to explore deeper the meaning of space syntax measures under the environmental criminological perspective. This is one of the goals that we are trying to address. And to further explore spatial crime impedance with fine-grained crime datasets, which is really hard to have also for given the privacy concerns. On the other side, from the ABM's point of view, we have to test the impact of every single variables. We have to test other theoretical assumptions, as we were saying. We have to go into depth also within the temporal exploration, since we aggregated, even within the ABM, in 4 hours to 4 hours scenarios. We have to include real-based heat maps driving pedestrian movement. This is a very important data that Crooks, for example, in 2016, in the model that he was using to drive the agents. And then in the end, add real data about commercial activities attractiveness that in this model was just estimated based on the type of commercial activities. So these are some of the works that we have done within the crime aspects that I was referring to. And I just thank you for your attention, and thank you again, Kimon, for the invitation. I'm here to address questions if you have some.